Today we're going to work, just give you a little bit of a review on what we did when we were graphing rational functions. F of x is equal to this. And if you remember, we did long division and we found something called slant asymptotes and we found vertical asymptotes, and we're going to do all that right now and just kind of do a little bit of a refresher for you. Let's do the long division first. That's going to be 3x cubed plus x squared plus 0x, because I'm going to fill that slot, minus 4, and I'm going to be dividing it by x squared minus 4. And my question is, how many times will this go into this? Well, it'll go 3x times. So over here I'm going to write 3x. 3x times x squared is 3x cubed. 3x times a minus 4 is minus 12x. There's nothing else I can do. Draw my line, change the signs, and add. And I get x squared plus 12x minus 4. Now I ask myself, how many times will x squared go into x squared? It will go once. 1 times x squared minus 4 is x squared minus 4. Draw my line, change the signs, and add, and I'm left with 12x. That means that this thing here, this big rational expression here or function, is equal to 3x plus 1 plus 12x over my divisor, which was x squared minus 4. Put parentheses around that to make it a little simpler. I'm going to do some erasing, and I'm going to talk about what's my slant asymptote and what are my vertical asymptotes. All from this thing right here. This part right here is my slant asymptote. That's it. From here, I'm going to have my vertical asymptotes, and those are wherever the denominator is equal to 0. Well, it happens that x equals plus 2, and it happens when x is equal to minus 2. 2 squared minus 4 is 0. Minus 2 squared is 4. Minus 4 is 0. So these are my vertical asymptotes. Let me write that off to the side. Vert asym are at 2 and minus 2. The slant asymptote is this right here. Now, I quickly want to check my end behavior. End behavior. This is the thing that was just a little bit of head math for everybody. We're going to do it again here. I'm going to make a little chart. I'm going to check when x is negative 2 and a little bit further to the left. I'm going to check when x is negative 2 and a little bit to the right. I'm going to check when x is plus 2 and a little bit to the left. And I'm going to check when x is plus 2 a little bit to the right. And all I'm going to do is look at this guy right here. I want to know whether it's positive or negative. When I'm getting very close to negative 2, I'm going to be heading very close to a negative infinity, or infinity which direction I don't know yet, because this is getting very small. So let's suppose x is a little bit left of -2. That means that x squared is going to be a little bit more than 4. A little bit more than 4 minus 4 is going to be positive. But up on top I have a negative because that's times a -2 something. So it's going to be a negative divided by a positive, which is negative. Then when I go to a little bit right of -2, this becomes a little bit smaller than 4. 4, a little bit smaller than 4 minus 4 is going to be negative. 12 times a -2 something, or a little bit less than that, that's going to be negative. Negative over negative is positive. Why don't I worry about this here? Because this will far outdistance anything that's happening here when you get close enough to these asymptotes. Now let's go over to the right. When we're looking at +2 now, and a little bit less than 2. A little bit less than 2 here is going to be a number smaller than 4. Minus 4 is going to be a negative number. But I've got a positive on the top, so positive divided by negative is going to be negative. And finally, when I look at 2 plus, this number here squared is going to be a little bit more than 4. A little bit more than 4 minus 4 is positive. Top is positive. I have a positive. Now I'm ready to do my graph. My slant asymptote is 3x plus 1. So here is 1 going up with a slope of 3. That's my slant asymptote. My vertical asymptotes are at 2 and -2. There's 2 and -2. So I have this line here, this line here. I wish I'd drawn it a little bit more, because this information tells me that on this side of -2, I'm going to be coming up and then down again, based on that. -2 plus means I'm going to be starting from up here. I'm going to go through that point there, because that's, I didn't cover it, but that's where my, when x is 0, -4 over -4 is 1. It goes through there. Then when I get close to 2 on this side, I'm going to be dropping down. And finally, when I do 2 plus, I'm going to be doing this kind of thing. So, wish I hadn't drawn it quite like that. This is going to be coming in kind of a slanted V kind of thing in the crook of these two asymptotes here. But it's always going to be lower than these asymptotes because of that. Hope this helps. See you at the test.